All right, so here's my example 6. We have the integral of 2 to infinity of 5x dx over the square root of x squared minus 3. So because your limits of integration, by the way, states that you're going from 2 to infinity, starting at 2, whatever number I plug into my denominator, you're always going to get a positive number, right? Inside of that square root. So you know that this function can essentially be continuous for the interval of interest from 2 to infinity. All right. So you apply your definitions. What we can do is the following. We could pull out the 5, our constant multiple, and multiply it by the limit as b approaches infinity from 2 to b of x dx over the square root of x squared minus 3. Now, x squared minus 3, well, to solve this particular integral now, you just can't find an antiderivative right away. You need to use a u sub. So for this integral, we're going to say x squared minus 3 is going to be our u. That u equals to x squared minus 3. Du is going to equal to 2x dx. Now, inside of the integral, when I rewrote it, we have the x dx. But since we have a 2 in front of it, I am going to divide 2 on both sides, or say that I'm multiplying by 1/2. So we get 1/2 of du is equal to x dx. All right. But there's also another thing that we have to do here. The other thing that we have to do is essentially change our limits of integration. Because I made a u sub, I would need to essentially just change my limits of integration here, okay? Now, the thing is, when I change my limits of integration, if I start with the lower limit, for example, when x was equal to 2, we are going to get u is equal to 2 squared minus 3, which is 1. On the other hand, we can't really say when x is equal to, I mean, we could say when x is equal to b, but for now, you could just say infinity, right? Because I want to look at the original integral. And then the original integral had the infinity symbol. And we know that b is approaching infinity anyways, okay? So when x is approaching infinity, x is equal to infinity, you're going to get u is equal to infinity squared minus 3. So what is infinity squared minus 3? Infinity. All right. So what we're really looking at now when we make a u sub is 5 times the limit as b approaches infinity of 1 over from 1 to b, right? Because remember, the upper limit of integration would have technically been infinity, but b is approaching it. So we're going to get 1 to b of 1 over the square root of u du. Now, the square root of u is just u to the 1/2. So because you're going to get u to the 1/2, and that's located in the denominator there, do you think this limit is going to converge or diverge? It's going to diverge. So we just have to show it, okay? We know that from our nice little fact that if the power of your single term, your monomial, your variable is between 0 and 1, and including 1, it's going to diverge. That's by the p-series test. One sec. So you rewrite u to the 1/2. You get 5 times the limit as b approaches infinity from 1 to b of u to the negative 1/2 du. Well, u to the negative 1/2, when you integrate it, it's just u to the 1/2 over 1/2. All right, just rewriting this. So this is from when u is equal to 1 to u equals b. All right, so the 1/2, you can multiply it take its reciprocal, multiply by the 5 on the outside, that will be 10. So you get 10 times the limit as b approaches infinity of now u to the 1/2, which is now b to the 1/2 minus 1 to the 1/2. Now, what is b to the 1/2? Oh, that's right. I forgot about that 1/2 from earlier. That's right. I forgot about this 1/2. So let me just fix that. So it should have been 5 over 2, 5 over 2, 5 over 2, 5 over 2. So technically, when I multiply by the 2, right, then this would have just been 5. Okay, thank you. All right. I missed that. Sorry. I was just too excited that the limit was going to go to infinity and it diverges. All right. So you have 5 times b to the 1/2. Well, b is approaching infinity, so it's infinity to the 1/2 minus 1 to the 1/2, which is just 1. This is just all infinity, so it diverges. All right.